Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Welcome to another episode of the Distributed Data Show. I'm David Bechberger. This is Jeff Carpenter. And today our guest is Dave Bechberger. And today we're going to talk about migrating an application using a legacy database to one using a graph-based solution. So Dave, I like that name, by the way. It's a good name. You know, it feels very familiar to me for some reason. I don't know what it is. But, yeah, it's a great name. So why don't you tell us a little bit about your background and, you know, how'd you even get into graph databases?
Yeah, so I've been doing full stack software development for about 18 years now. Actually, mainly focusing on the .NET stack for most of that time. And about 4 or 5 years ago, I kind of made the migration over to dealing with big data technologies. At which point, I kind of switched over to more of the Java Scala side. Started out just kind of dealing with a variety of different big data technologies, including Cassandra. And from there, I was working at a consulting company, and we were one of the initial. We used to work on graph databases such as Titan, and we kind of migrated across to working on DSC graph from the beta phase on. So I've actually been kind of involved in pretty much exclusively using graph databases for about 3 and a half, 3 years now.
Okay.
Yeah. What kind of graph database problems are you working on right now?
So right now I am the chief software architect for a company called Gene by Gene. What we do is we do genetic genealogy. So we're a competitor with companies you're probably a little more familiar with, someone like 23andMe or Ancestry DNA. Basically, you send us a DNA. You buy a kit from us. You basically get it. You swab your cheek. You send that back to us, and then we sequence your data, or we sequence your DNA and provide you out with the data. Part of the data that we provide to you is your genetic genealogy. So we are able to compare your DNA against the other people in our database to find out how you are related to them. So, is it your third cousin 3 times removed, or is it your aunt and uncle? And we're able to basically run that against our data or run your DNA against our data to be able to basically say, are you related, or roughly how closely are you related? One of the specific parts that we're working with right now is basically rebuilding out our family tree portion of our application. Being genealogists, building out your family tree and have that function well is a really crucial part to our website. So that is one of the things that we're kind of focusing on right now, is getting that part of our business, working very consistently, performant, and solid. Those things everybody wants in every web application.
Right. It's got to be fast. It's got to be reliable. It's got to be always on. This is like the table stakes, right?
It's funny too, because as he's talking about this sounds like it sounds like a good use case for graph. I feel like we should have Denise Gosnell on here right now, determining whether or not.
To provide like this is a graph use case stamp of approval.
I think we need to give her like a judge wig and have her like in the background.
Yeah.
And just have her rate whether or not this is a use case. But I think she would approve. I'm
pretty sure I know what the ruling would be.
So like, what made you, decide to transition your relational solution to graph? I mean, honestly, I think you started just touching on it from what I was hearing, but now I want to hear some of the details, like how'd that happen?
Well, and that wasn't all you too. I just want to interject, like, obviously they hired you as a graph expert, knowing, I think, like, foreshadow, like, that they wanted to be making this transition, right? But yeah, obviously there was some thought process that went into this. So
yeah. So, our current application so the company's been around for 18 years, and our application has been around for 18 years. So, it's as you would probably expect. It's a big monolithic application built on top of SQL Server. We're actually a .NET shop mainly, so it's built on top of Microsoft SQL Server. So it's, as I said, it's a .NET application built on top of SQL Server. And one of the big problems they were having, as you do with pretty much any monolithic application, is it was database bound. The performance of our website was completely dependent on the performance of our database. Since that database had grown organically over 18 years, as more and more features were added, as we all know, it was not exactly the optimal data model either. So what we kind of decided to do was that they were going to start basically taking that monolithic database and breaking it out into kind of vertical feature silos, and building those feature silos using different data stores for different problems and different and microservices to basically allow you to do all those great things that microservices do. Is I can change them as I need to. I can scale them up, scale them down, use my resources more efficiently. Those sorts of problems. So that was kind of how they came to the decision of they wanted to do some architectural changes. The first one they chose to do was actually one of the core features of our system, which is that family tree aspect. It's a genealogy site. Having your family tree is a little important to that sort of problem. So they basically, a couple of the other senior devs and one of the other senior architects kind of looked at the problem space and decided that looked at the problem that they were trying to solve and the different tools that were out there, and decided that they wanted to go with a graph database. At that point, that's when I came on to basically help them implement that out, because as we'll get into talking about here, making that switch is there's definitely definite gotchas in the whole switch to making it work.
Gotcha. Okay, so this is, I get the architectural context here. You're kind of transitioning from a monolith, carving off pieces of it, maybe a little bit at a time, and moving to what sounds like a little bit more of a polyglot persistence kind of approach, where different services might have different backing data stores behind them. Am I on the right track?
Yep. No, absolutely. You're absolutely correct. That's kind of where it's definitely going towards more of a polyglot sort of persistence, where we're trying to choose the best data store technology out there for the different problems that exist.
Okay, cool. So for at least some significant portions of the data, that right solution is a graph database.
Yeah. We're working through, as I said, we're kind of working through building out your family tree. I mean, what's the family tree? But it's just, it's a very recursive problem just by the true nature of it. It's a recursive problem where you want to then be able to query it to answer very graph sort of problems,
Right.
Problems like, how is this person related to this person? Well, if you want to find how two nodes in a graph are related to each other, it's very easy. If you want to do that in something like a relational database, it's very time consuming and difficult, and I don't want to write that CTE to make that happen.
Right.
Whereas something like graph, it's the simplest path query.
We've probably all seen examples of the multi-page SQL query to do some of these kind of equivalent to what a graph traversal would look like, right? So, okay, that makes perfect sense to me. But we all know in doing migrations like this, like just because you have a use case that's a good fit for graph, that doesn't mean that everything is easy peasy. And, these are obviously this is the big money-making system of the company. You're working on the crown jewels. I've destroyed a monolith myself before. It's not easy. So what were some of the challenges that you ran into in doing this migration?
There was a variety of different challenges. The first and probably most significant one is the fact that, the team I was working with, as well as pretty much, I would guess, 99% of, development teams out there are very familiar with relational databases and not as familiar with graph databases. So being able to kind of make that, being able to teach people how to actually think in a graph mannerism versus a relational manner, and work through the problems that a graph presents you that you don't have with a relational, and things like that. Because, in a relational, it's very, people are very used to how SQL works. Pretty much any developer that's been around for any amount of time can write a reasonably good SQL query. Mm-hmm. Gremlin queries are not quite as easy to learn, and it's a very different way to think about the same sort of problem. You're thinking about how you're traversing through your graph versus how I'm joining across tables and keys. So there was definitely some challenges in basically getting the team up to speed on how to think and work in a graph. If anyone that's worked with a graph for any amount of time finds that there's definitely a learning curve that you have to go through with that sort of thing.
Right.
The other thing was one of the key things we ended up kind of getting tripped up on was we were not only switching from a relational model to a graph model. At the same time, we were kind of switching from a response request ACID transaction sort of system to one that is eventually consistent in a web application. Well, if you're dealing with eventual consistency in a web application, you have to treat the problem a little bit different. I can't, create a family tree and then read it back immediately like you're used to being able to do. So we had to work through those sorts of problems as well.
Cool. Okay.
Okay. Well, so given those particular challenges, right, the ones you were just talking about, would you do it again the same way?
Yeah, I mean, actually, I would probably do it, well, the exact same way? No, of course.
Let's dig deeper.
Yeah, let's hear about it.
Definitely there would be some additional learnings I'm going to take from it. But yeah, I mean, I still think based on, what we're working on right now is really just kind of the foundation for a lot of the next level things we want to be able to do that the graph will enable us to do, as far as being able to match things and do all the great analytics that we can get with having all our information in a graph that are very difficult to do inside of a SQL server,
Totally,
a SQL server or any other relational database. So I think the benefits outweigh the cost. But I think, the one thing I would definitely do a little bit differently the second time around versus the first time around is invest a little more in that upfront training on those kind of two key topics I talked about. One being, graph, not graph theory so much, but basically I call it like pragmatic graph, There's the theory of how graphs work, and then you have to lay that layer of pragmatism on top of it.
That sounds like an O'Reilly book. Pragmatic graph.
Pragmatic graph.
It does.
Sound like an O'Reilly book.
Someone should write that book. Nice, but seriously, like, what resources did you use to get your team up to speed, your development team up to speed on graph? How did you? Because you got there eventually. At least I hope you did.
Well, the thing is, it's there was we probably started out with 4 or 5 people that were really learning graph, and we ended up with 2.5 or 3 of them that really kind of got it in the end.
Okay.
We were trying to do this as well as getting everything else done at the same time. So there's a distinct time investment involved in getting this up and working.
No, that makes sense. I've seen a parallel experience in a development team where I was working with, and they were coming up to speed on Cassandra, and it ended up that not every person ended up being the full-on Cassandra DBA. Right. With that level of data modeling skills, right? It's okay to have that specialization with your team, to be sure.
Yeah, well, it's not only okay to have that specialization with your team. I mean, my biggest concern was at least that the majority of the team understood the difference between the two and when one was right versus the other, because you don't have to, no one's an expert in everything,
right.
But it's really nice to know whether this is the right tool for the job or, I always think about it, the relational database is the hammer. If all you have is a relational database, everything looks like a nail. It's nice to be able to, expand it out and know, like, well, this is a screw and this is a hammer and, this is and I can do different things with different pieces of it, especially as we're moving from that, monolithic SQL Server application to a more polyglot persistence layer. It's very good. We wanted to make sure that people would be able to have the knowledge and freedom to choose the right tools to do the right job.
Right. So just a follow-up to dig in there a little bit more. I was curious about how your schema evolved over time. Did you really have, you're so good with graph databases and you know the problem domain so well that you just nailed the schema the first time? I mean, or was it, migration over time, and what did that look like?
Well, so with the specific problem we're solving with dealing with family trees, there was actually, there's a standard out there. It's called GEDCOM, GEDCOM.
Oh,
it was last updated in the 1995. It's kind of somewhere between a really bad XML and a really bad linked list sort of format.
I want to see this now.
It's interesting. So we actually, we wanted to be standards compliant because we wanted to be able to import and export these because that's the industry standard in genealogy. So we were able to at least use that as some of the basis of it.
Okay.
But getting the basic data model correct was relatively easy because we could use that as our basis of how it works. We had our domain model already set for us, but it was when we started layering all the other, value-added features that we do with our genetic aspects of it that it started to become a little more interesting about how we wanted to do that because it wasn't as well defined, and that definitely changed over time as we started going through the implementation phases.
So does that look like adding new vertex and edge types, or just is it more about optimizing and deciding where you need to put search indexes and that kind of thing, or is it all of it?
All of the above.
Okay.
It was all of the above. It was adding new vertexes and edges, or properties on vertexes or properties on edges in order to optimize, well, not only be able to optimize our queries, but optimize our search indexes. And since we kind of are using the same graph to do some analytical sort of queries and some transactional queries, we needed to be able to support both use cases, at least for some of our simplistic our simplistic analytics. So being able to have that data in a way that you could query it both as a transactional workload and an analytical workload, and it be reasonably performant, was a bit of an ongoing iterative process. I should say it is an ongoing iterative process. So,
yeah, as a matter of fact, as far as the performance aspect, I was actually going to ask a little bit about that. So, okay, right, you've got the model part and kind of the iterations you have to go through to kind of figure that part out. But then from the performance standpoint, like, was it a home run, the first hit, or did you find that you still also had to iterate through how you were, modeling your graph and stuff to get it to perform well, or how'd that actually work out?
No, I mean, we definitely had to iterate through, you started out with what you think your best guess data model is. But it definitely took some iterations to not only get the data model in a place that we could traverse it quickly, but also get optimize the traversals and the indices on those traversals to basically make it so we could handle a couple of different, handle our different queries in different ways. And, in a couple of places, we ended up having to denormalize data down into, different vertices from, from other vertices in order to be able to get a performing query. Because, if you're trying to traverse out and have to hit, 5,000 vertices, it's going to be a lot slower than if I only have to hit 1,000.
That's true. Yeah.
Nice. Okay. So, yeah, and as David was hinting at, you definitely had to figure out how to kind of scale up, and in order to see what the performance was going to be. Do you have any advice for somebody who's just starting out? How do they know, or how, maybe it's a testing question, maybe it's a load testing kind of question more specifically, like how do you, when you have a schema, how do you know that it's going to perform? How do you build up the scale and really see if you have the right schema?
So kind of, the approach we took was we looked at what our realistic load on from our customers were, and what the realistic amount of data sizes we were pulling back were, and then we kind of worked towards optimizing towards those. Because I can make you a data model that you can pull back 10,000 vertices really quick, but if you're only ever going to pull back 100, why do I want to go through that headache of making that work?
Yeah, that's a good point.
So it was really about first off, it's knowing your data, knowing your data, and knowing how you're going to query it. Graph is much like Cassandra in that way. If you know how you need to know how you're going to be able to query it out in order to be able to optimize for it. That's, the same is true with the relational model as well. If I know that I need to be able to pull these two things out at the same time, maybe I want to denormalize them down into the same vertices, so I don't have to make an extra traversal or extra traversal hops out in order to pull that data back and then mix it back in the end.
Gotcha. Okay, good. So I know that you've already shared with us about how you would definitely make sure to train up your team before you get started on a big graph project. Do you have any other advice for somebody out there who is ready to embark on a graph database effort to incorporate that into an existing or a new application?
Yeah, I guess one of the other pieces of advice I would say is, come at it with an open mind, in as much as if you're used to working in a relational mindset, don't try to directly translate your relational mindset and your relational expectations to a graph. You can put a relational database directly into a graph, but it's not going to be optimized. At the same time, there's definitely some downsides you want to be aware of using a graph. The one that was probably the largest complaint from my team was basically the lack of as robust a tooling as you're used to with relational databases. Relational databases have been around for 40 years. They have better tools around them. It's just,
right.
Graph databases have maybe been around for 10 at most. They're still...
at least in kind of the modern form, to be sure, right?
Yeah. I always kind of think of graph databases as they're like teenagers. You can eventually get the information out of them that you want, but it takes a little bit more work than you really want to put into it sometimes. It's a little bit harder than it should be.
Right. Well, it does seem like there's a lot of effort going into the tooling, and I think that's like a teenager. eating a lot and growing rapidly, right? I think that's the same for the maturity that I think is that we're really starting to see emerge from the graph databases and the tooling around them.
Absolutely. I think that's actually one of the biggest areas I see graph growing right now is the tooling and making the tooling better and easier to use for people that aren't necessarily graph experts.
Yeah.
The ability, even just like with DataStax Studio, to be able to visualize the results of your query was a huge step forward from a green screen console. Those sorts of tooling and those sorts of improvements are tremendously beneficial to actually trying to really get a graph up for productization, I should say.
Mm-hmm. All right, well, thanks, Dave. I really appreciate it. That was awesome. And thanks, everybody, for watching another episode of the Distributed Data Show. See ya.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.